All right. So the first thing that we notice looking at this is we're talking about the number of ways to order. And again, that word order is the most important word for us. All right? Order. Most important word. Okay. I've got everything color coordinated here for you, so I hope you can see what it means. Let's just real quick go through how to use the formula. Then we'll talk about why to use the formula. So what is 5p3? How would I put that in a formula? 5 factorial divided by? Okay. It would be 3 minus 2. Oops, I said that wrong. I'm so sorry. 5 minus 3 factorial. I'm so sorry about that. 5 minus 3 factorial. But in reality, I know that 5 minus 3 is what? 2. So it's 5 factorial over 2 factorial. Now, this is new for us, so we probably do want to write it down correctly. But once we do a bunch of these, we'll probably skip and jump right down to here. Okay? So anyways, this is just evaluate like you did yesterday. 5 times 4 times 3 times 2 times 1 divided by 2 times 1. And of course the 2 1s go away. And you're left with 5 times 4 times 3. And the answer is 60. Any questions? So on this second example here, set this up for me. It would be 10 factorial over, it'd be 10 minus 2 factorial, or in other words, it would be 10 factorial over 8 factorial. Now, of course, that's a little bit longer. You don't have to write it all down, but that's 10 times 9 times 8 times 7, 6, etc. And then on the bottom, it would be 8 times 7 times 6, blah, blah, blah. And you end up with the 8, 7, 6, 5, 4, 3, 2, 1 all canceling. And you're just simply left with the answer 10 times 9 is 90, right? All right. So on this one, if I follow, it's going to be 4 factorial divided by 4 minus 4 factorial. What is that? That's 4 factorial divided by 0 factorial. All right. We haven't talked about this yet. We need to define what 0 factorial means. It doesn't really make sense to go from that all the way down to 1, does it? Okay, so 0 factorial doesn't really make sense as far as what we talked about on our definition yesterday. So it's been defined for us already by the math gods in front of us. In order for everything we do with factorials to work, 0 factorial is always equal to the number 1. So that's just one of those facts to memorize. 0 factorial is always equal to the number 1. So that means down here, 0 factorial is really just the number 1. So this answer is really just whatever 4 factorial is. And 4 factorial is 24. Yesterday, we talked about having 5 chairs, right? And I was going to choose 5 people to go sit in those chairs. And we even did this. We stood up and we decided how many there was, right? And we ended up, I think it was 5 times 4 times 3 times 2 times 1, right? 5 people. The first person had 5 choices. The second person only had 4 choices left. The third person only had 3 choices left, and then 2 choices left. And then the last person only had 1 choice left. And we had 5, 4, 3, 2, 1, which was about 120, remember? Okay? So when we did 5 people, when we had 5 chairs and we were trying to put 5 people in them, we had 120 ways for that to happen. That was yesterday. But now, this problem here, actually, what it says is this. It says, hey, instead of having 5 people with 5 chairs, I'm going to have 5 people, but only 3 chairs. So 2 people don't get to sit down. Okay? So my question is this. If I have these 5 people up here, how many different ways can they sit down? So I'll name these people A, B, C, D, and E. Okay? Just, Anna and Bob and all them people. So I've got the people A, B, C, D, and E. Those are my 5 people. Now, these 5 people might sit down like this. A, B, C, and then D and E didn't make it, did they? Or, what's another way they could have sat down? They could have sat down A, B, and D. And maybe C and E don't make it. Or it could have been A, C, and E. Right? And the question becomes, how many different ways can this happen? Okay? And the answer is the order. The answer is a permutation, because guess what? The order matters here. The way that I have this written down, ABC would be different than ACB, wouldn't it? Okay? So the order matters. And that's where we are on this problem. So this problem here actually becomes, how many ways can 5 people, no, I said that, yeah, 5 people sit in 3 chairs. Okay? And that's what this goes for. Now, let me give you a better example. What we're looking at in this situation, clearly order is very important. First and second and third is way different. In other words, if I finished A, B, C, that's different than finishing C, B, A. I did not write what I said. C, B, A, right? That's a different finishing order, isn't it? So, think. Does order matter? Yes. If order matters, the first thing you write down is a permutation. P. So we're going to do a P. How many people are running in this race? 8. How many do we want? 3. So it's a 8 choose 3. Now it's just like those other problems. So we got 8 people divided by what goes on the bottom? 8 minus 3 is 5. So it's going to be whatever 8 times, 7, 6, 5, 4, 3, 2, 1 divided by 5, 4, 3, 2, 1. And of course, those cancel. And I'm left with 8 times 7 times 6. 336 ways that can happen. Does order matter? And the answer is yes, it does. Because a vice president and a president are different people. So order does matter. So this is a permutation. How many people are running? And how many do I want? 4 positions to fill. So it's a permutation of 10 choose 4. 10 factorial over 10 minus 4 is 6 factorial. So you end up with 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And then the 6, 5, 4, 3, 2, 1s all cancel, right? So whatever 10 times 9 times 7 is? 5,040, 50, 40. So there are 5,040 ways for that to happen. So without talking about why order is not important, just how to use the formula, 5 choose 3 would look like 5 divided by what? 3 factorial, and then 5 minus 3 is 2 factorial. Do you notice the difference? You have 2 things in the denominator. So you have an extra divisor. So what's going to happen to our numbers? They're going to be smaller. They're going to be smaller if you're dividing by an extra number, right? So all of these answers should be smaller. So that would be 5, 4, 3, 2, 1 on top. You've got 3, 2, 1, and a 2, 1. Does anything cancel? Yeah. Take out this 3, 2, 1 and maybe this 3, 2, 1. And that leaves you with 5 times 4 on top, 2 times 1 on the bottom. So 5 times 4 is 20 divided by 2. And of course your answer is 10. Remember what the answer was on permutations? It was 60, wasn't it? 10 is a lot less than 60, isn't it? All right. 10 choose 2 is going to be 10 factorial divided by 2 factorial times 8. 8 factorial because it's 10 minus 2. Notice right here, 2 plus 8 is 10, right? And over here, 3 plus 2 is 5. That's always going to happen. So just kind of look for that. So that gives me 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, right? Over, here's a 2 and a 1. And here's a 8, 7, 6, 5, 4, 3, 2, 1. And do you have some things that cancel? Sure, everything from 8 down cancels. But you still have 2, 1 on the bottom, right? So basically this is 10 times 9 is 90, divided by 2 times 1 is 2. 90 divided by 2 is 45. Ends up being 4 factorial times 4 factorial over 0 factorial. And of course we just remembered that 0 factorial is really just 1. So my answer here is 4 factorial over 4 factorial, which is just 1. You can write it all out if you want to, but look, same numerator, same denominator. In this situation, instead of running the finals where order matters, gold, silver, and bronze, order does not matter because the top 3 people will advance. And it doesn't matter which order you finish in. As long as you make the top 3, you will be in the finals. So the order doesn't matter here. If I finished in ABC order or if I finished in CBA order, these 3 people are still making it to the finals. So this is a combination. As soon as you say, does order matter? If the answer is no, it's a combination. So this combination would be 8 people, and you're going to choose the top 3 that finish. And now it's just a regular old problem. So on this second situation, you can see that one was 56. On this second situation, again, we have 10 students running for officers this time, but this time the committee is going to lead. Not a leader, not a president or vice president, but all 4 of the committee. So if my top vote getters were A, B, C, and D, would that be the same thing as if my top vote getters were C, D, A, and B? Yeah, it's the same committee, right? It doesn't matter which order they finish in. It's the same 4 people. So does order matter? No, which means this is automatically a combination. And it would be a combination of 10 people choose the top 4, which ends up being 10 factorial over 4 factorial times 6 factorial. And if you'll run those numbers for me. All right, so I'm looking at this situation. In a passcode, is the order important? Is the combination 1, 2, 3, 4 different from the combination 2, 1, 3, 4? Yes. Yes. So is order important? Yes. If order is important, we know we have a permutation. So how many different ways can I mix up the numbers 1, 2, 3, and 4?
24 times.
How many different ways can I do that?
24.
It is 24. Yes. Because I have these 4 numbers, 1, 2, 3, and 4, and I'm going to mix them up, all 4 of them, right? So I have 4 numbers, I'm going to choose all 4 of them. So that ends up being, sorry about the red pen there, that's going to be 4 factorial divided by what? 0 factorial, which is really just 4 factorial, which is 4, 3, 2, 1. It's 24. So there's 24 ways that I can mix this up. 24 ways to mix up 1, 2, 3, and 4, right? Now, how am I supposed to find probability? Probability, remember from the other day, what do we do for probability? We take the number of favorable outcomes, which is 24, divided by what? The number of possible, total possible. So here's the question. How many possible combinations are there with a 4-digit passcode? Now I said the word combination. I didn't really mean to say combination. How many different ways can you make a passcode?
30.
How many is that going to be?
300.
Is the order important?
Yes.
Yes. How many do you get to choose from? 10. You have 10 digits to choose from. I'm not limited to 1, 2, 3, and 4 anymore. I have 10 digits to choose from. So this is a permutation. I have 10 digits to choose from, and how many am I going to pick? Just 4 of them. So I need to know how many is that. That's going to be 10 factorial divided by 6 factorial, which is 10 times 9 times 8 times 7. About ready? So, what we see right here is, as far as probability goes, we had to do a permutation to find out how many ways to mix up the 4, 3, 2, and the 1. There's 24 ways to do that. We had to know how many possible ways there were for the entire passcode, which was 5,040. So what's the probability? Go ahead and divide. 24 divided by 5040. If it's 0.0047, that's about 0.47%. Less than half of a percent. You feel better about your locks now? All right. So as you guys recognized, okay, these 3 red marbles, it doesn't matter. Out of my 5 red marbles in there, it doesn't matter if I pick this one, and this one, or in any order. Okay, so in any order, it doesn't matter. So is order important? No, so this is a combination. How many different ways can I pick 3 red marbles? How many red marbles do I have? I have 5 to choose from, and I only need how many? 3. So 5 choose 3 would be what? That would be 5 factorial over 3 factorial times 2 factorial. So you guys can run that number. You guys run that number. So you guys said that was a 10 when you ran that combination. Now, this 5 choose 3, that was just telling me how many reds. How many possible ways could I reach in that bag and get any 3? Order still doesn't matter, does it? Okay, I have 10 in there to choose from, and I'm still picking any 3 of them. So 10 is the total, right? So now I've got to do 10 factorial over 3 factorial times 7 factorial. Go ahead and run that number. So if it's 10 for this combination and then 120 for this one, 10 divided by 120 is 0.083 repeating. So that's about 8.3%.